Every year, 14,000 ships pass through a canal that should not exist. It was designed to fail. For 9 years, it did. The French sent tens of thousands of workers into the jungle to dig the Panama Canal. An estimated 22,000 of them died. The canal you see today was built on top of that failure. Different men, a different understanding of what had gone wrong. Before a single lock was sealed, before a single ship passed through, this was one of the largest engineering failures of the 19th century. And then somehow it became the opposite. Ferdinand de Lesseps was not an engineer. He was a diplomat, a promoter, and by 1880 the most celebrated builder of public works in the world. He had organized the cutting of a canal through the Sinai Desert. When he announced he would do it again through Panama, investors rushed in. He was wrong about almost everything. The question worth asking is not why France failed. It is, what did the Americans understand that the French didn't? And why did it take a decade of catastrophe to figure it out? William Crawford Gorgas did not arrive in Panama to build a canal. He arrived to fight a war the engineers hadn't even acknowledged. Gorgas was an American military physician who had spent years in Cuba tracing yellow fever transmission. His anti-mosquito campaign in Havana had by 1901 nearly eliminated yellow fever from that city. In 1904, he stepped off a ship in Colon in Panama and looked at a workforce the fever was still consuming. The canal would not be built by steam shovels. It would be built, or fail, on whether a mosquito could be stopped. De Lesseps had designed a sea-level canal. No locks, no elevation changes, a straight cut from the Atlantic to the Pacific, as at Suez. But Panama was not Suez. The Culebara Cut was one of the largest excavation projects ever attempted. Crews drilled holes into the rock face, packed them with dynamite, and detonated. Then 95-ton steam shovels moved in, loading rubble onto flat cars. At peak, a spoil train left the cut every minute. Workers were on site 6 days a week, 10 hours a day, in temperatures above 86 degrees. Landslides struck without warning, burying men and equipment in seconds. Between 1882 and 1889, an estimated 22,000 workers died, the majority Afro-Caribbean laborers from Jamaica and other Caribbean islands. In 1889, the company went bankrupt. Construction stopped. When the United States took control in 1904, the first American chief engineer lasted less than a year. So did the second. The problem was not ambition, it was sequence. Yellow fever spread through the bite of Aedes aegypti, malaria through Anopheles, both bred in standing water. Gorgas understood that the canal could not advance until those diseases were controlled. If a single cistern went unscreened, the fever returned within weeks. He fumigated buildings house by house, drained swamps, screened every water container, and treated standing water with oil. By late 1906, yellow fever was effectively eliminated, one of the most significant public health achievements of the 20th century. May 20th, 1913. 2 steam shovels working from opposite sides of the Culebra Cut reached each other at the center of the Continental Divide. Their buckets touched. The men around them, Americans, Barbadians, Panamanians, Spaniards, set down their tools. No one had announced this moment. It simply arrived. The final barrier across the isthmus had been cut through. A ship would soon be able to pass from the Atlantic to the Pacific without rounding Cape Horn. The decision that made the American project possible, and that de Lesseps had refused to make, was the lock. Chief engineer John Frank Stevens proposed a different design. Dam the Chagres River, raise ships through locks to an artificial lake at 85 feet above sea level, carry them across and lower them on the Pacific side. 3 chambers at Gatun on the Atlantic, lock complexes at Pedro Miguel and Miraflores on the Pacific. The Gatun Dam created the largest artificial lake in the world at that time. Steel mitre gates weighing over 700 tons each were operated by electric motors. The tolerances were measured in fractions of an inch. The same isthmus that had killed tens of thousands now had functioning hospitals, clean water, and a malaria rate that had fallen dramatically. The knowledge came from a Cuban doctor named Carlos Finley, who proposed the mosquito transmission theory in 1881 and was ignored for 20 years. The canal was built on science that already existed. The delay was not technological, it was the refusal to believe. The French had steam shovels, dredges, and cranes. What they lacked was a willingness to change the fundamental design when the original proved unworkable. Goethals, who replaced Stevens in 1907, had spent his earlier career building locks and dams on the Tennessee River. He standardized the supply chain and imposed a logistical discipline the project had never had. The Culebra Cut continued to produce landslides through the entire construction period. In 1913, a major slide delayed the final excavation by months. The mountain slid, the workers dug, the channel held. The Panama Canal was built by a deliberately segregated workforce. American workers, white, were paid in gold. Caribbean workers, predominantly black, were paid in silver. The distinction was formal, codified, and enforced at every level. The men who dug the Culebra Cut, who poured the lock concrete, who drove the steam shovels through the worst of the landslides, did so under a system that classified them as a different category of labour. Some names appear in some records, many do not. The canal opened on August 15, 1914. The first vessel to make the official transit was the SS Ancon. Europe had just gone to war. The United States exercised sovereign-like control over the canal zone until 1999, when authority was transferred to Panama under the Torrijos-Carter Treaties of 1977. Panama has since expanded the canal. A third set of locks, opened in 2016, now accommodates vessels carrying over 14,000 containers. The original locks still operate, not because the technology was never replaced, because it was built to a standard that made replacement unnecessary. The French failed not because they lacked ambition or equipment. They failed because they designed a solution before understanding the problem. The Americans succeeded because two men were willing to stop the project before it could proceed. Gorgas stopped to eliminate the disease. Stevens stopped to change the design. Both decisions cost time. Both made the canal possible. The locks at Gatun still fill and empty on the same principle. Mitre gates, electric motors, refined but not replaced, more than a century on. What was built here was not just a passage between oceans. It was proof that scale alone does not solve a problem. Sequence does. These systems shape the world quietly. If you'd like to see more of them preserved, consider subscribing, and tell us which forgotten engineering project should we document next.